Hello. Hope you're doing well. You're probably getting tired of this chapter, but it's almost over. This is actually the last section in this chapter. So if you enjoyed it, I'm sorry. You're probably going to be a little bit sad. But if you're not sorry, then don't worry. We'll move on to bigger and better things. Okay. So in the last section, what did we do? We saw that you can use the slope and the y-intercept of a line to graph the line. And I think in the last section I had mentioned in this coming section, which is what the section we're in now, what we're going to be doing mostly is they're giving us, instead of us graphing the equation of the line, they're going to be giving us information about the graph, and they want us to give them the equation of the line. That's something kind of new, because usually we're given the equation, and then they want us to graph it or give them information about the graph, like what's the slope, what's the y-intercept. So this section is kind of going backwards. They want us to find the equation. Kind of interesting. Okay. So that's kind of what I just mentioned in here. That's the idea of this section. What if we're given information about the graph, and then they want us to find the equation? Let's see. I mean, we'll look at how to do it. There's step by step here, but just to read the first example, just to see what we're getting into. In this example, they say they want us to find the equation of the line, which that means that in the end we should have y equals mx plus b, where, like we mentioned before, the only variables should be x and y. So our job is to figure out, to replace the slope and the y-intercept. Variables should be x and y. Okay, so if we can replace m and b, that's all that matters. All right, but the tricky thing is, you notice, okay, if I want to use this equation, y equals mx plus b, okay, in this example, I was given the slope, so I'm free to just replace that right now. -6 can go in there. But you notice the point. The bad thing is this point is not the y-intercept. Because remember, y-intercept, it's always of the form, here, maybe I'll say it up here. Remember the y-intercept, it's always going to look like 0, comma something. So if you're given a point that looks like that, 0, comma something, then you do have the y-intercept. But notice the point that we're given is not 0, comma something, it's 5, comma something. So they haven't really given us the y-intercept. I don't know b. They have given us another point. So that point, it will allow us to find b, but b will not be either of those values. B will not be 5 and b will not be -3. We'll have to find another way to use that point to figure out what b is. So be careful. You're not going to replace b with either of those values. You could only do that if you were given a point, like we said up here, of this form, 0, comma something. Okay, so it's kind of more difficult, but we kind of have an outline here of how to go about this. So the first thing you're going to do here, step 1, kind of like what we thought to do, is if they give you the slope like they have, you're just going to go ahead and replace it, because that's exactly what you need. So I'm going to replace m with -6. That's the easiest thing to do right off the bat. Okay. Got it. -6x plus b. And then the last two steps, step 2 and step 3, they're there to help us figure out how to find b. Okay, so the next step, maybe I'll label that was step 1. Step 2 is it says you want to replace, okay, what does it say? Replace the x and the y in y equals mx plus b. Okay, so we're going to replace this x and this y here with the coordinates of the point xy. So remember they gave us a point here. They gave us, 5, -3. And of course, a point, that's an x value. So 5 is x and -3 is y. Like it says, I'm just going to replace those values. If y is -3 and x is 5, I should be able to replace those guys. And then leave everything else the same. -6 times that. B is the thing we don't know, so I'm going to go ahead. Yeah, let's see. So we're going to replace x with 5 and y with -3. That was what we just did. Then at this point, like it says, the last part of that is you're going to solve for b, which seems possible because I notice in this equation now there's only one thing I don't know anymore. It's the b. So right now we have -3 equals -6 times 5 is -30. But now I should be able to solve for b. I just have to isolate it. And all that's left to do now is to move the 30 over. Okay, there's b. Now we know it. B is going to be what? -3 and 30 is 27. Aha! Now we found b. So the good thing is we were given -6 for slope. The bad thing is they gave us a point which didn't really give us the y-intercept right off the bat, but it did allow us to find it. And now we're ready for the last step, which is kind of just like the finishing touch. Now that you know the slope and the y-intercept, you can just go ahead and replace those guys. Okay, because it's supposed to be y equals mx plus b. And now that I know both m and b, I'm just going to go ahead and replace those guys, and I will be done. M is -6, b we just found to be 27. Aha! There it is, beautiful. So it's kind of a lot of work, but the good thing is all you're doing is using this one formula that we've already probably memorized by now without even trying. Y equals mx plus b. Okay, I know that's kind of like a whirlwind of information, but like I said before, the more of these you try, the better you'll get at them. So let's see about this next one. This next one's almost, basically the exact same thing. It's just a different slope and a different point. So what do we have here? First thing, I'm going to think about the equation I'm going to use. Y equals mx plus b, that's all you need. And I look at what I'm given, I say, okay, they gave me the slope, 2/3, and they gave me a point, 6,7. So the slope, that's exactly what I need to put here. I'm going to replace that guy. But remember that this guy is not the y-intercept. If it was the y-intercept, the x-coordinate would be 0, like we talked about up at the top. But it's not, so I can't replace b with anything yet. But the first step would be, I want to replace m with the slope. And now the rest of this problem is all about trying to find b. Okay, but we know another point, like we said, it's 6, 7. So 6 is the x value, 7 is the y value. I'm going to replace, in the equation that I just wrote there with m equals 2/3, I'm going to replace x with 6, so x with the x value, and then y with 7, y with the y value. If I do that, then I should be in a good place. So here I got a y, but I know I want to replace y with 7, like we said here. Okay, then equals 2/3 x, but we said we want to replace x with, what, 6 here, huh? And go ahead and do that, 6. And I would always put it in parentheses so I don't forget what's going on between. If you put 2/3 and then 6, you're not going to know what the operation is. So it's good to write that in parentheses. So we got 7 equals, and now that I look at this, I know that, okay, I'm multiplying a fraction, 2/3 by a whole number, 6. I better put that whole number over 1 and then see if I can either multiply across or reduce. But I notice this one reduces, huh? Because 3 can go into 6 twice. So in that number there, you're just left with 2 times 2, which is 4. Then you could say over 1, but I mean, anything over 1 is that number. So this is really 7 equals 4 plus b. And if you want to solve for b, all you have to do is subtract 4 from both sides. Because, maybe I'll erase that over 1, because it looks kind of confusing. We just know that, it ends up being 4 over 1, but 4 over 1 is just 4. So if we subtract 4 from both sides, 3 ends up on the left side, and then on the right side, b is all by itself. Okay, we finally know b, and we already knew m before. M was 2/3. So the very last step is just put everything together. Remember that the equation of the line is y equals mx plus b. So now that we know both m and b, we can replace those guys. M was 2/3, and b we just found to be 3. So there it is. Beautiful. That's a beautiful thing right there, you guys. It's kind of a lot of work, huh? Or it seems like, but maybe it's not. Yeah, it is. It's a lot of work. But the good thing is it's only using that same formula. Just got to remember what to do. And I think the biggest trap to fall into is thinking that the point you're given, like in this one we were given 6, 7, thinking that that point just gives you the y-intercept. But it eventually does give us that. We have to do a lot of work, but the y-intercept is neither 6 nor 7. It's going to be something else that's not obvious right away. So be a little bit careful. Okay. So far, so good. Let's see about this next example. We're going to be doing more of the same thing. They're just kind of going to give us the information in a different way. In example 3, they say, find the equation of the line parallel to the line x minus 5y equals 1 and containing the point -1, -6. So notice this doesn't sound exactly like the last problem, because remember in the last problem they gave us the slope. They said m equals bleh, and then they gave us a point. So the point is normal, like we've seen that in example 1 and 2. They gave us a point in both of those, but in examples 1 and 2 we were given the slope. So notice that the different information they gave us was that the line we want is parallel to this guy. So I'm thinking, okay, why didn't they just give me the slope? I wish it was slope instead of this weird information, oh, the line is parallel. But then I remember, oh yeah, I remember parallel lines have the same slope. Lines, same slope. So really when they say that our line is parallel to this guy, that means if I find this guy's slope, the slope that we want is exactly the same. Because again, two parallel lines have the same slope. So all I have to do is find this, or the first thing I need to do is find the slope of this line we're given. Then since the line that we want is parallel to that line, I should be able to say they have the same slope. Okay, but again, we've seen this so many times by now. How do you know the slope of a line when you're given the equation? Well, we're going to have to isolate y, because you need it to be in that form y equals mx plus b. And then once it's in that form, we'll say, oh look, the coefficient of x is the slope. So if I want to isolate y, the first thing I'm going to need to do is move the x over. That way I'll have negative 5y by itself. And then I could have 1 minus x, but like we've seen before, you want to write the x term first and then the constant. So I'm going to write negative x plus 1. And then to really get y by itself, I'm going to divide every term by negative 5. That'll really get y by itself. And then we'll finally be able to identify the slope. So okay, that will give me y equals, okay, we've seen this before also. If that's, well, it's a negative over a negative, which is a positive something, but I want to extract the coefficient of x. So I don't want to write it as x over 5. I want to write it as something times x. So what times x equals x over 5? It would be 1/5. It's a little tricky, but be careful about that. If you have x over something, you can always rewrite it as 1 over that thing times x. And in the constant term, we have a positive 1 divided by a negative 5. Well, negative 5 does not divide into 1 evenly, but at least I can write it as subtracting 1/5. Instead of a positive divided by a negative. I know a positive divided by a negative is a negative. But actually, you know what? That's kind of a moot point, because what do we really care about here? The whole point of doing this was to get the slope. The slope is just the coefficient of x, so 1/5. Okay, so like we said before, the whole point of that, they said the line that we want is parallel to this line. So since the slope of this line was 1/5, that means our line has the same slope. Same slope. So that means if I want to, I can just say, all right, the slope I'm looking for, that I thought I was missing from this problem, I now know it, 1/5. All right, so now, finally, after all that work that we did in this example, we're actually just where we started in the previous examples. Because in the previous examples, they gave us the slope and a point. So it's a lot more work. We had to go figure out what the slope was. Now we're ready to do the steps that we did in the last example. Remember, in the last example, the first thing we did was take the equation y equals mx plus b and replace the slope with the number they gave us. So 1/5 is the slope. And unfortunately, b we won't know yet because this point they gave us doesn't have b in it. That's going to allow us to find b, but it's not exactly b. And then now the next thing is, I want to remember that this point I was given, the negative 1 is the x-coordinate, the negative 6 is the y-coordinate. So I should be able to replace the x with negative 1 and the y with negative 6. So it looks like negative 6 equals, the slope was 1/5 times x, but x is negative 1, and then plus b. Okay. This doesn't look pretty. I'm going to see, how can I simplify this? I got negative 1 times 1/5. I'm going to put the negative 1 over 1 and then see if I can multiply those. The left side, there's not much to do, right? It's just negative 6. Then over here, if I multiply across, 1 times negative 1 is negative 1. 5 times 1 is 5. Okay. If I want to solve for b, okay, I could move the 1/5 over. But you know what? I'm not too excited about combining or trying to find a common denominator. Because imagine if you move the 1/5 over, it'd be 1/5 and negative 6. You'd have to add them together or subtract them. You'd have to get a common denominator, and I'd rather not do that. So if you remember, we had a little shortcut. If you have an equation with fractions in it and you don't like the fractions, like here, 1/5, you can take the least common denominator of the whole thing. Then here, there's only one fraction in this equation, so the least common denominator would be that denominator. I'm going to erase some of this stuff to give me more room. Sorry. So the LCD here would be 5. And that's because there's only one denominator. Remember, our trick was if you want to get rid of your fractions, you can multiply the entire thing by that LCD. So I'm going to take 5, the least common denominator, multiply it by every term. Well, there are only 3 terms, but I think it's going to make it a lot prettier. So we got, okay, on the left side, 5 times negative 6 would give me negative 30. And then we have 5 times negative 1/5. Maybe I'll write that out so I don't make a mistake. 5 times negative 1/5. And then lastly, you have 5 times b. I can do that. That's 5b. All right, now if I want to multiply the 5 and the 1/5, I want to put that 5 over 1, and I notice that these cancel the 5s. So in that term, all you're left with is really negative 1. So it looks like negative 30 equals negative 1 plus 5b. And I know this has taken a while, but I'm very happy that I can solve the rest of this, or I can solve for b at this point without having to deal with any fractions. So if I want to isolate b, I'm going to move the 1 over first. Add 1, and then what do we have? I'm going to move this up here. Negative 30 and 1 makes negative 29. And on the right side, all that's left in that equation is 5b. And if I want to isolate b now, finally, last step would be divide by 5. There we go. So b is this terrible fraction. Oh my gosh, who comes up with this stuff? Negative 29/5. That's pretty bad. Come on. Whew, that seems like a lot of work, but we're almost done. The last step is just put everything together. I want to have the equation of the line. And the equation looks like y equals mx plus b. As long as I know m and I know b, then I should be good. And I put a plus for b, but it should be a minus, because b is negative. So slope, we found the slope a while back. It was 1/5. And then b we just found, it was negative 29/5. Aha. Whew, that's a terrible equation, huh? Wow, but hey, what are you going to do? We did it. All right, that was a doozy, but, oops, sorry. But these get a little easier, I think. This next one's a little easier. And it's mostly the idea behind it that you want to keep in mind. It's not necessarily all the tough arithmetic and all the fractions and everything. It's the steps that are really important. So be careful. Just take your time. Don't rush them. All right, let's see. Example 4. This one's very similar. Just remember in the last one, they said, find the equation of the line that's, they said last time, parallel. This time it's perpendicular. So if you remember from the last section, perpendicular lines have reciprocal slopes with opposite signs. So that's good to remember. That's going to help us here. So it's really similar to the last one. Yeah, they gave us a point, okay, just like in the last one. And they said, well, last one though, they said parallel to some line, but now we're looking at perpendicular. So what we're going to have to do, kind of like in the last one, we're going to have to take that equation they gave us, 3x minus 5y equals 6, and then try to solve this guy for y. Once we have y by itself, we'll be able to identify its slope. Once we have the slope of this line, we can find the slope of the line we want because we'll look for the reciprocal that has the opposite sign since they're perpendicular. Okay, so if I want to solve for y, I'm going to first move the 3x over. All right, then I'll have negative 5y by itself. And then I'm going to write negative 3x and then the 6 because you want it to look like mx plus b. And then I'll get y by itself if I just divide everyone by negative 5 here. Okay, we're all done now getting y by itself. Y is equal to, I have a negative 3 over negative 5. That makes a positive 3 over 5, x. And then a 6 over negative 5 makes a negative 6 over 5. Although the 6 over 5 part doesn't matter, right? All we wanted to know was the slope. The slope is the coefficient of x. So we know the slope of the line they gave us, but remember, if we were looking for a line that's perpendicular to that, we want to think about, like it says here, what's the reciprocal of that? So I got to take 3/5, find its reciprocal, which means I'm going to flip it upside down. So instead of 3/5, I'm going to write 5/3. But also, not only that, you want it to be the opposite sign. So since the slope of that previous line was positive 3/5, I'm going to make mine negative, the reciprocal, 5/3. Okay, so this is a little more thinking involved than the last example, because the last example, since I said parallel, once I found the slope, it was exactly what I wanted. But in this one, perpendicular lines don't have the same slope. They have, reciprocals that are opposite signs. Okay, so we finally have the slope, and then we had a point as well. We haven't used that yet, -4, -7. But we're going to do, now we're finally where we were in example 1 and 2 in this section. We're going to finally be able to use the equation y = mx plus b. First thing I'll do is replace m, since now we know m is -5/3. I'm going to be able to replace that guy. Okay. Looks good. And then remember, your next step is you got to remember that the point they gave me, let me move this up here, they gave me -4, -7. So that's the x value and the y value. I'm going to go ahead and replace the x and the y value in the equation y = -5/3 x plus b. Replace the y with the y value there, -7. And then replace x with the x value, -4. This one it's kind of feeling like deja vu, huh? Like I feel like I just did this problem very similar in the last example. And it's true, we did. And then we'll have to solve for b. Once we solve for b, we're pretty much home free. So okay, now where are we? We have -7 equals, okay, I'm going to put this 4/1 here. And notice nothing reduces. So I'll just have to multiply across, but I do see it's a negative times a negative, so it's a positive. And in the numerator, it's 5 times 4, so 20, over the denominator, 3 times 1 is 3, plus b. And this is it's kind of up to you. You can solve for b by subtracting the 20/3 over, but then you'll have to combine 20/3 with -7, and you have to get a common denominator, and I don't enjoy that. So I'm going to do like we did in the last one, and multiply this whole thing by the LCD, which is 3. I'm going to multiply it by this -7, multiply it by the 20/3, and multiply it by b. And I think that should work out pretty well. So what'll happen there? Okay, so we're multiplying these guys. 3 times -7 on the left side would be -21. And then, you know what? I think we can do this quickly. I'm going to go, now we're multiplying 3, the LCD, by the 20/3. Maybe I'll write that out, just to be safe. 3 times 20/3. Okay, let me move this a little bit over here. Then the last thing we're multiplying is the 3 outside, the LCD times b. Well, 3 times b, I can handle that, 3b. Okay, so try to simplify this fraction here. If I put that 3/1, notice the 3's cancel outright. So all we're left with in that term is 20. So it's -21 equals 20 plus 3b. All right, and then we'll be almost done. I'm going to try to isolate b by subtracting this 20 here. Then we'll have -41, that's kind of a random number, equals 3b. And the last step to isolate b will be to divide by 3. Whew, there it is. So that's a terrible number. I don't think I would have guessed that value if I had a lot of guesses. b is -41/3. Oh my goodness. All right. Now the last step is, like we saw before, just put it all together. Y = mx plus b. Replace the m with what you know and replace the b with what you know. So m, we found that a while back and I already forgot what it was. But it's a good thing I boxed it over here. M was -5/3. And then b we just found was -41/3. It's kind of a really ugly answer, huh? But what are you going to do? Sometimes that happens. Now, so those problems, that's probably as bad as they get. If you can do that, I think you can do anything in this section, or this whole chapter, actually. Those are pretty bad. Okay. So if you need a break, if your mind's kind of blown, don't feel bad. You can pause the video, go take a walk, go eat a snack or something. I don't blame you, because that was a lot to take in. These last two examples I think are a little easier. I think. They're just a little different. But still, every single problem in this section, our goal is to find the equation of the line. It's just in these last two examples here, they're giving us different kinds of information. Remember in the first two examples in this section, they gave us the slope of the line and 1 point. And we were able to find the equation of the line. But in this one, you notice they gave us 2 points and no slope. So it's going to be a little extra work. What we're going to have to do is first find the slope. And what you'll have to do is use an old formula from a couple sections back. Remember, the slope between 2 points will be y2 minus y1 equals x2 minus x1. That's the one extra step we'll have to do. We'll have to do that first, and then we can use the slope. And actually either point. It's up to you. Okay, so we'll jump into it. Let's see. So probably what I want to do first is, like we said, find the slope. M equals our trusty formula, y2 minus y1 over x2 minus x1. But those 2 points, I think what I'd like to do, like we did before, is label them. x1, y1, x2, y2. So I remember where each one goes. I'm going to rewrite this guy here. We got, okay, that's y2 minus y1 over x2 minus x1. So what was y2? y2 we labeled for -9. Oops, try to use a different color there. -9. And then y1 we labeled as -3. So be careful, there's a subtraction and a negative. The subtraction from the formula, a negative because y1 was -3. And then in the denominator we have x2, that's -4. Oops, and then we're subtracting x1, ooh, that's another negative, so be really careful. Got a lot of subtractions and negatives here that are easy to miss. So now that numerator, you have -9 minus -3. That's -9 plus 3, which is -6. Over -4 minus -1, that's -4 plus 1, which is -3. So you have -6 over -3, which is 2. Actually, you know what? That's not a bad slope, huh? I think that's pretty nice. Okay, so that was the extra work we had to do. But now once we have that, we now know the slope. Now it's just like it was in examples 1 and 2. We have the slope. Let's see, we have m equals 2. Then kind of as I mentioned here, you're going to use the slope in either point. So it's strange, but you have to choose one of these points that we were given and just stick with that. And it's funny because it doesn't matter which one. You'll get the same answer in the end of this problem eventually. It's kind of nice. So since I know I'm going to get the same answer no matter which one I choose, I look at them and I say, which one has smaller numbers? Because I like smaller numbers. -1, -3. I mean, sure. If you're feeling kind of adventurous, if you want, you can try the other one. Try -4, -9 and finish this problem. And you'll see that we do get the same equation. It's funny. All right. So like I said, now we're in the same place we were in example 1 and 2. We're going to follow those steps that we were given. We're going to take y equals mx plus b and replace first the slope. Since, again, this point here, this -1, 3, that's not the y-intercept, so I'm not able to rewrite what b is. The only thing I do know is that the slope is 2. So that's one thing I can replace. Yeah, since we found out the slope was 2. And then the next step would be, I see my point, it has an x value, -1, and a y value, -3. I'm going to replace those guys for x and y. So since y is over here, I'm going to replace y with the y value of the point, -3. And the x value is here. The x value of the point I chose was -1. So I know if you chose to use the other point just for fun, this right here is going to look a lot different. It's going to look like -9 equals 2 times -4 plus b. But once you solve for b, it's funny, you'll get the exact same b, which is crazy, right? Math is amazing like that. Okay, let me try to rewrite this guy. We got a -3 on one side, and then it's 2 times -1, that's -2, plus b on the other side. And now b won't be so hard to solve for. I just have to move the 2 over. Okay. So it's -3 plus 2, that's -1. There's b. All right, we have b, and then remember earlier we found the slope was 2. The last step, just kind of the finishing touch, would be take y equals mx plus b and replace the m and the b with our values. So slope is 2, b is 1, -1. I always put a plus. Why am I doing that? -1. Okay, so there's the equation of the line. It's y equals 2x minus 1. Whew. All right. Looking good. All right, that was a lot of work, but I do feel like, I don't know if you agree, but it seems like that last example was less work than example 4, though. Example 4 seemed like pretty complicated, but maybe it's all in my head. Okay. Good thing is example 6 is exactly like example 5. We're going to do the exact same thing. Oops. Sorry about that. What did we do? We took, what is it? Yeah, we said we want to first find the slope, because we're given 2 points. Once we find the slope, then you're back exactly where you were in examples 1 and 2. So it's going to be the exact same thing. I'm going to try to first find the slope. M equals y2 minus y1 over x2 minus x1. In this example, I kind of got scared because I saw decimals. But don't worry, it'll work itself out. So I'm going to label these guys. This is x1, y1, and this is x2, y2. I'm going to go ahead and replace the values in there. We got y2 comes first. y2 is 5, because that's the y value of the second point. And then y1, -4. Be careful, because it's 5 minus -4, since the formula itself had a negative. And then in the denominator, we have x2, that's 3.2. And then subtract x1, x1 is 1.2. But if you think about how those guys subtract, you're going to get a whole number, and it's not really scary anymore. So, okay, the numerator, you have 5 minus -4. That's like 5 plus 4, or 9. And the denominator, 3.2 minus 1.2, that's exactly 2. It's like 3 minus 1, basically. And then since it's not a whole number, I'm just going to leave it that way. I mean, some people might say, oh, can you make that a decimal, 4.5? Because 2 goes into 9, 4.5 times. But when we're talking about equations of lines and slopes and things like that, we always want the slope to be a fraction. So keep in mind, you wouldn't want it to be a decimal. I think in real life, if if you had a line that represented something in real life, you might want it to be a decimal. But in the math world, where if you have no context, then it's preferred to have fractions instead of decimals. Okay, so now that we have the slope, we just found the slope was 9/2. Okay, now we can choose either point. It's totally up to us. Either point. And that's kind of a tough one, because I noticed the first point, it has 1.2 and 4, which are smaller numbers than 3.2 and 5, but 3.2 and 5 are both positive numbers. I don't know. What do you think? The first one, why not? Doesn't matter. So yeah, if you chose the second one, you're going to get the same answer as us either way, so don't worry. Alright, so I'm going to use the slope in that point, and the first thing, like we've done before, the first thing you want to do is replace the slope in y equals mx plus b with the slope 9.2. Or sorry, 9.2. 9/2. Hello. So y equals 9/2, and then x plus b, since I don't know either or any of that stuff. Alright, we're getting there. Now we're going to find b by saying, I'm going to use this point. The x value is 1.5 and the y value is -4. So here's y. I'm going to put -4 where that guy was. And then here's x, 1.5. I'm going to replace him. But everything else is staying the same. Whew, okay. Looks good, looks good. So now the next thing I want to do, this is kind of complicated here, huh? 9/2 times 1.2. Probably just for this part, to do that computation, I'm thinking, if 1.2 was a whole number, I could put it over 1 and multiply across. Let's just do that. Never mind. What was I going to say? Yeah, let's just do that. So I have -4 equals, okay, I'm going to multiply across, which is weird. 9 times 1.2, you can always go off and do that to the side, let me think. What is it? 9 times 1.2. Okay, that'll be 10.8. Okay. 10.8 over, if I multiply the denominators, 2 times 1 is 2. Okay. And then this looks strange, the 10.8 over 2. But I think what I'll want to do is write that guy, or make it a decimal, I'm going to divide it. 2 can go into 10.8 how many times? 2 goes into 10 5 times. And it goes into 8 4 times. Aha! It must be 5.4. I'm going to rewrite that here. Let's see, because we're kind of running out of room. -4 equals, all right, we just did 10.8 divided by 2 is 5.4 plus b. Now we almost have b by itself. Let me subtract this 5.4 here. Okay, so that's good. Let's see, -4 and -5.4 is -9.4. There we go. And you know what? Now that I think about it, since we have a decimal b, right? That's not a fraction. But I think, you know what? I'm sorry, I should have said this earlier, but when we found the slope, you know, I said 9/2 is preferable. I think in this one, actually, if you wrote the 9/2 as 4.5, that would have worked out as well. Since you're getting a decimal b, you might as well have everything in decimals. Okay, so I don't know. It doesn't matter fraction or decimal. But our last step is to put everything together. Y equals mx plus b. I'm going to replace m with the slope and then b with the y-intercept we just found. And yeah, it's up to you, but I mean, I guess to keep everything consistent, the b is going to be a decimal anyway. You might as well write the slope as a decimal as well. And then the b we just found was 9.4. There it is. In all its glory. Okay, that was tough, you guys. But it was interesting, right? Or no? Maybe not. No, it was. This is fun. No, this section's very difficult. So I think if everything made sense, you're doing really well and you should be feeling pretty good. If it didn't make perfect sense, don't worry. It just takes practice. This is definitely one of those topics where you have to get your hands dirty and try a lot of problems. And then it'll make a little more sense every time, even though you won't feel too comfortable. And then eventually it'll make more sense, but these take a lot of practice because you got, like, what do we have up here? We had a slope formula we had to use, and then we have to use y equals mx plus b. It's just so much to remember. So hopefully it made a little more sense. And again, if you kind of forget, you can always come back and watch the video again later. Especially fast forwarding to the parts that are the most difficult to get the hang of it again. Okay, well, hopefully it made sense. If you really hate this chapter, it's over now, if that makes you feel any better. We'll start a new chapter in the next section, and hopefully it makes a little bit of sense, and I hope you followed along pretty well. All right, I'll see you in the next video. Thanks for listening. Bye.